Hello, MGA. My name is AJ. Thank you for joining this session. Today, I am very happy to talk about how we can use satellite data to monitor and forecast the air quality from space. Without further ado, let's get started. Under this presentation, there are 4 parts. First one, I will talk a little bit about my organization and what we do, and then I will talk about the background of how the scientists use the satellite data to monitor the air quality. And then the third part will be how we use the machine learning to create the forecast module of the air quality application. And the last part, I will give you a live demo. First one, I am working for the Serbia Mekong, where we work with the regional partners in the 5 lower Mekong countries, including Myanmar, Laos, Thailand, Cambodia, and Vietnam. We are promoting the use of the satellite data, as well as we have developed the geospatial tools to facilitate the better decision making. As you see here, we have developed several tools, the land cover, the surface water mapping, and one of the flagship tools is the Mekong Air Quality Explorer, which I will talk about this in the part 3 and 4. Now let's talk about how we can use the satellite data to monitor the air quality. Let's look at the classical way of air quality monitoring. The authorities use the ground station to measure and report the air quality. As you can see here, this is a part of Bangkok, Thailand, and those points are the stations which report the amount of PM 2.5, which you can see from this legend. The blue is very good, very healthy, and until the red one, which is very dangerous to health. And then the question is, how can we fulfill the gaps where there is no ground station? All right, let's look at the global level. In here, this is the satellite data, is the global aerosol observations from space. And they are the aerosol optical depth. Okay, the blue one means this is a good condition, not much aerosols, and the red one, this is a lot of aerosols. Okay, now we have one term, the aerosol optical depth. I will elaborate this in the next slide. From this slide, you see the satellite data can provide a unique ability to understand the spatial and temporal variability in aerosols, which is not possible from the surface measurements, right? What is the aerosol optical depth? Let's see this. The aerosol optical depth, it is a measurement of the total aerosols, okay, including urban haze, smoke particles, the dust in the desert, or even the sea salt, which is distributed within this column of air, you see, from the Earth's surface to the top of atmosphere. Okay. And what about what happens down here at the Earth's surface? We also have the ground station. All right. So the scientists had put so much effort in estimating the PM 2.5 or some other particles from these aerosol optical depth column by using this ground station. Okay. And then if you want to know more how to do that, please pause this video right now and follow this link. All right. And then let's look at one example in Australia. The scientists try to find a correlation between the surface PM2.5, okay, which is measured from the ground station, comparing to the aerosol optical depth, the AOD from the satellites. And you see the AOD speak the same way. For example, this is the event of the forest fire. Let's see the before the fire, during the fire, until the after fire. During the fire, it creates a lot of smoke, right? A lot of PM2.5. This is the surface PM2.5. And look on the right, the AOD data says the same. Okay, that means we can do something with the AOD. We can estimate the PM2.5 from this AOD data. Let me bring you to the global picture. On the upper left, these are the ground sensors. The ground sensors, by far, it gives the most accurate measurements, okay, of the ground air quality. All right, these dots. They are the locations of the ground measurement stations. Okay, and then look at the lower right. This map is the population density. What I want to say about these two maps is that you see some part of India or Africa or even in the United States, there are no there are no station measurement at all. Okay, even the US, which is the most completely instrumented country in the world, some parts, they do not have the ground stations. Okay, that's why the satellite data can fill those gaps. Okay, and then after we could fill those gaps, here comes the satellite's estimated PM2.5. See, it gives you a power of monitor the air quality across the space and time. All right, that's the monitoring part using the AOD data. Okay, and then let me scope down to the Mekong region. See the map on the left. Here is the true color image. Okay, and then you see this is taken in February 2020. It was when we had a bad pollution situation, and you see the thin smoke layer, okay, throughout Thailand and the other countries, especially in Bangkok, in the box, okay. And then when we use the AOD data from the satellite, we can see it more clearly. Very red one here means a lot of particles, a lot of aerosols in this region, okay. And then not much on the photo on the right. This is the real photo taken from the building the same day, February. All right, that was the monitoring part, okay. And then what about, let me talk a little bit on my job. One of the tool, which is called the Mekong Air Quality Explorer tool. This is how we formulate how we develop the tool. First of all, we use the satellite data and model, okay, and then we also use the ground measurement, all right, and then we create the machine learning algorithm. In this case, we are using the random forest algorithm, and next we create the interface, the online visualization, and then we compare with the authorized AQI of the specific countries. Okay, we started this project with Thailand, and then let me explain more. During the model development phase, we use the GEOS climate model reanalysis, such as the MERA2 reanalysis data. with the meteorological data and aerosols components and the ground data the whole year of 2018. And then we put all of this into the machine learning models. Then we do the validation. We use the 75% of the ground data for training and the rest for the testing. And after we came up with the model, the machine learning model output statistic right here, we use that model to calibrate the GEOS climate data. Okay, and that's how we came up with the forecast data. And here is the result of the training data. We have the x-axis is the observed data from the ground, right? And the y-axis is the estimated PM2.5 from the GEOS climate model. Okay, of course, after validated and bias corrected. We have a good R square. Okay, and then all the 10 folds, they have a consistent result. What I want to emphasize here is that our model still says the positive bias for a very low PM2.5, as you see here, very low PM2.5, and then it tends to undershoot. And then for the I'm sorry, the overshoot, the positive bias. I'm sorry, the positive bias for very low PM2.5. And what about very high PM2.5? We estimate we give the negative bias for very high PM2.5. Our model always say they undershoot, always undershoot the PM2.5 value. Excuse me. And the same thing happens when we do the validation. We have the positive bias for very low PM2.5 right here, see, and then the negative bias for very high PM2.5 value. All right. And here I give you the link to the application. Please pause this video and follow through this link. Okay. And here just the static page of how the tool looks. It looks just like the mapping application you use every day. Let me bring you to the real demo. Okay, after we have the model set up, and then we build the front end interface. Okay, to support the use of the scientists in the partner organizations. In this interface, now you see two data. Okay, the first data is the ground station ground measurement from the authority. In this case, this is the data from the Thailand Pollution Control Department, and this is the 11 o'clock. Okay. And then the second data is the GEOS climate model, okay, right here, that we can see the estimation of PM2.5 in every inch on Earth, okay, not only where the station is located. And now let me introduce to the special feature how we can see the forecast data. Okay, I click on this station. See, it will draw the graph. And in this graph, you see two lines. The black line is the amount of PM2.5 from the ground measurement, okay, from the ground data, from the ground station, okay, and it stops somewhere at the present time, okay, at the most present time. This is in the morning of today, January 27th. And what about the green line? Green line is the forecast data from the GEOS model, okay, using machine learning to calibrate the model. So it doesn't stop here today. It goes into the future, okay. until maximum 3 days in advance. This will help the government to better inform their citizens to better prepare if the air gets worse or better in the next 2 or 3 days, okay? Or even to manage the pre-burning schedule, or even to manage the agricultural burning for farmers. All right, I think that's it from my presentation. And thank you once again for joining this session. Please follow those links I have given here for more information. And see you again in the next class. Bye.